Okay, so depending on what book you're using, as I said, we're trying to make this book in specific, but we're probably moving on to what's a different chapter now. And this is another picture. Remember the one I drew initially, way back in the day now. So here's some angle beta. This is y, this is x, this is r, which is x squared plus y squared square root. You'll also see this in terms of opposite, adjacent, and hypotenuse, okay? And all of these things are the same. Remember, so what do we have? Sine of beta is equal to y divided by r. So from this picture, the sine of beta is opposite, which I'm just going to cheat and HYP. I think clearly, hopefully this is just all the same. So, the reason why we're using words now instead of x's and y's is, remember, we got into a bit of trouble every once in a while when I wanted to use x's and y's, but we are already in the coordinate plane with x's and y's and it wasn't really working out. So sometimes for a generic triangle, if somebody says opposite over adjacent, so if somebody says what is opposite over adjacent, so opposite divided by adjacent, that's this divided by this. In this case, it would be y divided by x. This would be the tangent of beta. So this would be the tangent of beta. The reason why we're going to start using these a little more is now we're going to start constructing triangles, right? And you know these relationships. You know that sine squared plus cosine squared is equal to 1. All of the identities that we've been using are going to be consistent. Let me go right to the homework problems. Basically, we're going to be building triangles with some minimal information. Actually, we're going to start using this stuff in a real practical kind of way. Suppose, so one of your problems is this. It says, so here's your triangle. Here's theta, they're calling it theta. Here's M, H, and D. And they want us to do all 6 trigonometric functions, okay? So they want us to figure out what is sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Okay, so the first thing that you know is what is sine. So sine is adjacent divided by hypotenuse. Hopefully, if you've been watching these lectures, this is just like you're going, oh, dude, I'm so bored. It's this divided by this. It's h divided by m. Similarly, cosine is adjacent divided by hypotenuse. And this is going to be d divided by m. And tangent is going to be opposite divided by adjacent, which is h over d. And now you know that cosecant is upside down sine, so it's just m over h. And that looks like an n. So secant is just cosine upside down. That's just m over d. And cotangent is just tangent upside down. This is going to be d over h. I remember when I was in school where you guys are right now, and I didn't particularly like this opposite over adjacent thing. I don't know why. I guess the picture that I drew of the x's and y's just always made better sense to me. I guess this is just another way for you to think about these things. Let's do something a little more practical. And actually, so if there are any surveyors that are in the class, congratulations, we're finally going to get to see what you're going to do for work. This is the basics of what you're going to do for work. It gets much more complicated. Incidentally, you're going to make a fine living too, and it's a good job if you can get it. So they have this. They want us to figure out the rest of the information about this triangle. So we're given 30 degrees, and the book is using 30 degrees. Remember what I said, how you kind of need to go back and forth between degrees and radians? When is it proper to use what? Anytime in physics, you always use radians. That's pretty much standard. But here's 150. information? No. So in these exercises it says find the length of h on the side of the right triangle without using a calculator. Well, okay, so they're saying without using a calculator. The reason why is because they hope that you know what sine of 30 degrees is. Remember, so the sine of 30 degrees is also the sine of 6, which is 1/2. So the sine of 30 degrees is 1/2, but what is sine? Sine is this divided by this, opposite divided by hypotenuse. So 150 divided by h is equal to sine of 30 degrees, right? This is just by definition what sine is. However, this is equal to 1/2. So we have 150 over h is equal to 1/2. Hopefully it doesn't take too much algebra to see that h is equal to 300, okay? And how did I know that just in case? Well, multiply both sides by h, and then multiply both sides by 2, these cancel out, these cancel out, and you have h is equal to 300. Incidentally, if we want to complete the information on this triangle, what is this? Well, so by Pythagoras' theorem, incidentally, this is a right triangle. It's going to be this squared is equal to this squared plus this squared, so this squared must equal this squared minus this squared, and I should just write it. So this is 300 squared minus 150 squared square root, whatever that is. Actually, let me see what that is, and then let's see if we can figure some more stuff out about this. So 300 squared minus 150 squared square root. Okay, so this is 259 and change. So 259.8 something. So if that's true, let's make sure that that's right. So how am I going to do that? What is the cosine of 30 degrees? Well, hopefully you know it is the square root of 3 over 2. So I'm going to do this 30 degrees and hit cosine, right, which is what it is. What is this? The cosine is going to be this. So I claim that this is 259.8 divided by this, 300. This is supposed to equal the square root of 3 over 2. And this is basically equal to 0.86602 and change. So let's see if it worked. Let's just make sure that the calculation came out right. 259.8 divided by 300, and it is 0.866. So, this has been very simple, I get that. We're going to be moving on to some harder problems. But as you can see, we're going to start using sines, cosines, and tangents to take a minimal amount of information and construct a larger picture from it. And this is really data compression, which is probably the most single important thing in all of computing, all of your DVDs, all of this video that we're making. I'll see you in a minute.